Now we are going to have a look at a few proportion questions. Problem number 13. Shobha and Shanti have to dust all the ornaments, 100 of them, in their house every week. If Shobha does it on her own, it takes her 1 hour and 40 minutes. If Shanti does it on her own, it takes her 3 hours and 20 minutes. If they do this together, how long will it take them? Very common proportion question where we have two rates or ratios that we have to combine. So I started off by writing down what they gave me, and I'm going to write it down as a ratio. So you can see there that Shobha will be cleaning 100 ornaments in 1 hour and 40 minutes. And what I did there was just to convert the 40 minutes to a fraction. Now to do that, you just take 40 minutes, 40 divided by 60, and that is how I got the 2/3. Then for Shanti, she can clean 100 ornaments in 3 hours and 20 minutes. And again, I converted the 20 minutes to a fraction just to get everything into hours. Now, I want to get these 2 hours basically to the same amount of hours, because if they work together, I want to compare the amount of ornaments that they will clean in the same amount of time. So we want to convert these hours. Now what I did here was I took a 3 and a third, I converted it to an improper fraction, and I did the same on the left hand side here for Shobha, and I got 5/3. So I want to get 5/3, I want to get to 10/3. So that was quite easy for me to see that I just needed to times the left and right by 2. And then I've got Shobha's time at 10/3 hours. And I can see that she will clean 200 ornaments in 10/3 hours. Whereas Shanti in the same amount of time will clean 100. Now, if they work together, that means in 10/3 hours, if they work together, how many ornaments will they be cleaning? So putting that together, you add the ornaments in the same amount of time. So this is the ratio of them working together. And all you need to do now is convert this 300 back to 100, because you see, you want to know how long will it take them to clean, the 100 ornaments. So what I did here was, again, to get the 300 to 100, I divided by 3 on the left. And because this is a ratio, you do the same here. So you take 10/3 and you divide that by 3, which gives you 10/9. So now the 10/9, this is hours. So you can just convert this using the calculator. The SD button gives you the amount of hours. And of course, you want to convert all of these 0,11, all of these decimals, you want to convert that to minutes, because that's just awful. We know that this is a whole number, so that's going to be your 1 hour. And then without the 1, you're going to have 0,11, into infinity. There's a lot of decimals, so keep that in the calculator. Times that by 60 to convert it to minutes, and then you've got 1 hour and 6,66 minutes. Okay, so that is how long it will take them to work together. You can also go further here. Let's just see. You can convert the 0,66 minutes to seconds as well. So there you go. So you've got 6 minutes. So we've got 1 hour. That's a full 6 minutes. And this is 0,66 minutes, which you can convert to seconds. So the 1 hour and 6 minutes is actually then, well, that's 60 plus 6, right? Because 1 hour is 60 minutes with another 6. So together that's 66 minutes, and your 0,66 minutes converts to seconds. And then you've got your final answer in minutes and seconds. A small cartridge can print 360 pages. 4 small cartridges can print as many pages as 3 medium-sized cartridges. 5 medium-sized cartridges can print as many as 4 large ones. How many pages can a large cartridge print? Now, just take it bit by bit. It might sound a little bit confusing, but if you go one by one, then it's not actually that bad. So I started off with the first one, and just to explain what I did here, this is my first ratio given. A small cartridge can print 360 pages. So this is a small one. One small one can print 360 pages. 4 small cartridges can print as many. Okay, so let's stop there. I want to know how many pages can 4 small cartridges print. So I had to work that out because I need to use this answer for my next size. So I then times this ratio by 4 on both sides. So now I can see 4 small cartridges is going to print 1,440 pages. Now let's read on. That will print as many pages as 3 medium-sized cartridges. So let's stop there. 3 medium. So I'm going to write it here. That's my 3 medium cartridges can print the same amount of pages as 4 small ones. So I'm putting my 144, these are the amount of pages that 3 medium cartridges can print. Let's read on. 5 medium-sized cartridges. So let's work out how many pages can 5 medium-sized cartridges print. So I needed to get an answer of 5 there. So I need to take 3 and times it by something to get 5. Now, to do that, you can use a fraction there. So if you times 3 by 5 over 3, you will get 5. So you must just times the pages with the same amount with that fraction. So that tells me that 5 medium cartridges can print this amount of pages. Now let's read on. 5 medium-sized cartridges can print as many as 4 large cartridges. So, okay, so I know that 2,400, 5 mediums, okay, prints 2,400 pages. That will be the same amount of pages for 4 large ones. So that goes into my next ratio. And now finally, what's the last question? How many pages can a large cartridge print? So I want to know 1 large cartridge. There it is. 1 large one. So let's just delete this one. Okay. So I'm already looking at large versus pages, but I want 1. So to get that answer from 4 to 1, you just divide by 4 on either side, and that gives you 600 pages. So 1 large cartridge can print 600 pages. So it's actually not a very hard question. You just need to go from the one ratio to the other, using the one to fill in the other, to finally get your answer. Harry inflates 8 balloons every 3 minutes. Every 10th balloon bursts immediately after it has been inflated, while all the other balloons remain inflated. How many inflated balloons will Harry have after 2 hours? Okay, so let's read this again. Harry inflates 8 balloons every 3 minutes. Every 10th balloon bursts immediately after it has been inflated. So what I need to figure out, and this is what I did here on the left-hand side, I wanted to find out, how many minutes, after how many minutes does it take for the 10th balloon to be blown up. So every 10th balloon will burst, and that will happen every 3,75 minutes. So I knew that I had to work with the 8 to 3 because this is the amount of balloons that's blown up in every however many minutes. So there's 8 balloons in every 3 minutes, but I wanted to know, how long does it take to get to 10 balloons? Because that 10th balloon is going to burst every time. So I times by 10 over 8 to get to 10. Did the same with 3 times by 10 over 8. So it takes 3,75 minutes to get to every 10th balloon. Okay, let's read on. Let's read on. While all the other balloons remain inflated, every 10th balloon bursts immediately after it has been inflated. Well, how many inflated balloons will Harry have after 2 hours? So after 2 hours, that is going to be 120 minutes. So on the right-hand side, what I wanted to check was how many balloons would I have blown up by, 120 minutes. After 2 hours, how many balloons will I have? Using the 8 to 3, I know that from 3 I need to get to 120, so I'm timesing by 40, and I did the same on the left. So 8 times 40 gives me 320 balloons. So this tells me there will be 320 balloons in 2 hours, but every 10th one burst. So how many balloons burst? So I need to figure out how many 3,75 minutes will there be in 2 hours, because every 3,75 minutes a balloon will burst. So if you divide these two, you get 32 balloons. This gives you the total of balloons that will burst in your 2 hours as you are blowing the balloons up. So I know that there's in total 320 balloons, but 32 of these will burst. So the amount of balloons that will be inflated at the end is 288. Very nice question. In a group of 108 people, 1 in 4 has a pencil and 1 in 3 has a pen. What is the minimum possible number of people that have something to write with? Now this can be solved in quite a few ways, and I think I'll discuss both with you. But just looking at logic here, I worked out, if 1 out of 4 people in this group is going to have a pencil, I wanted to know how many out of the 108 people will that be. So I said a quarter of the 108 people will have pencils. And if you work that out, that gives you 27 people. And then a third, 1 out of 3 people of the 108 people in the group will have pens. So what is the minimum amount of people that will have something to write with? And now you need to understand that it might happen that some of the people that are writing with pencils might also have pens. So it's not that, out of the 108 people, 27 have pencils only, and 36 extra only have pens, but they don't overlap. So your worst case scenario, which means your minimum amount of people that will have something to write with, might be the 27 people. That's the minimum that will have pencils, but they also might have pens. So how many pens then are left? So the minimum 27 that have pencils might also have pens. Thus, out of 36 pens, there are an extra 6 people that will have pens only, which means there's a minimum of 36 people in this group that will have something to write with. That is worst case scenario. If all the people that have pencils also have pens, then this is what will happen. Now, another way to look at this is to maybe we use a Venn diagram. That's not in your syllabus yet, but it's very easy to understand if you look at it visually. So what I have here, I drew a big circle, and inside this big circle, I'm calling this all the people with pens, and you can see that is a total of 36. So if all of this adds up to 36, and inside of this circle, there's a group of people that have pencils, and they might also have pens, you see. But I know there are 27 people with pencils. But if those 27 people with pencils also have pens, they will lie within the circle of pens. And together, if I add up all the people with pens, that will give me 36. So the minimum amount of people that will have something to write with will be 36 because the pencils are lying within the pens set. That might make a little bit more sense if you see it visually. The other scenario, and this is now not part of the question, but I just wanted to show you what is the maximum amount of people that will have something to write with. So now you are assuming that all the people with pens don't have pencils, and all the people with pencils don't have pens. So now the two sets are completely separate. There's none of the people that overlap. You can see there's no people that might have pens and pencils together. We are seeing this as worst case scenario for the maximum amount of people to have something to write with. And then you just add the two together. Okay, so yeah, I think seeing it visually might make more sense for the logic. On a construction site, an experienced bricklayer can complete the brickwork for a single house in 5 weeks. Another bricklayer takes 6 weeks, whilst an apprentice learning the trade takes 10 weeks. By maintaining their working rate and working together, how many days are required to complete a single house? So again, ratios here works wonders. I looked at the bricklayer 1 and I just wrote down the ratio that they gave me for bricklayer 1, and they said that this guy can build a house in 5 weeks. For bricklayer 2, and just ignore the calculations for now, for bricklayer 2, he can build one house in 6 weeks, and then for bricklayer 3, this is the apprentice, he can build one house in 10 weeks. Now, if you look at the original ratios, again, you want to get all of them to the same amount of time. So there we've got 5 weeks, there we've got 6 weeks, and here we've got 10 weeks. We need to convert all of the weeks in all 3 ratios to the same amount of time so that we can put their amount of houses that they can build in the same amount of time together to work out, how many of the house they can build together. So what I did here was I times by 2, 5 weeks to get that to 10, and I did the same on the left. So now I know that bricklayer 1 can build 2 houses in 10 weeks. Then I needed to get the 6 to 10, so I times here by 10 over 6, both sides, and I get 10 over 6. 10 over 6 houses in 10 weeks. And now if I put that together, I need to add all of these houses together. So in 10 weeks, if all of them work together, we've got 2 plus 1 plus 10 over 6. You can just plug that into your calculator. Well, you're actually not allowed to use a calculator, so you can just work that out on the side, and you get 14 over 3 in 10 weeks' time. So how long will it take them to build one house? You see, that's what I needed to work out. One house, how do I get this to one house? I need to divide it by 14 over 3. Do the same with the amount of weeks. So divide that by 14 over 3, which is the same as timesing it by 3 over 14. Remember, you are times and tipping there. And again, this is the amount of weeks. So you want to times that with 7 to get to the amount of days in a week. And that gives you 15 days on the dot. A farm has black cows and brown cows. Suppose that all the cows of the same color give the same amount of milk every day. 4 black cows and 3 brown cows can give as much milk in 5 days as 3 black cows and 5 brown cows given 4 days. What is the ratio of the amount of milk given daily by a black cow and that of a brown cow? So you can see what I started off with is just to represent the liters per day that a black cow and a brown cow will give us, because we don't know what those amounts are. So I just made that X and Y. Now looking at the first scenario there, they said that 4 black cows and three brown cows give as much milk in 5 days as another scenario. So we are actually looking at the total amount of liters of milk made together. And they are comparing one situation to another, and those amount of liters in both the situations are the same. So this is technically an equation that you need to set up. Your left, which is your first scenario, is going to be equal to your right, which is your second scenario, and that will give you the same amount of liters of milk. So if you look at my first scenario, this is in 5 days, my 4 black cows. So to get the amount of liters in 5 days, so that's 4 black cows. I know that black cows can give me X amount of liters per day, so I'm timesing that by 4, plus my 3 brown cows, and I times that by 5 because that's for 5 days. Now the amount in total here will be the same as the total on the right hand side, where I have 3 black and 5 brown cows in 4 days. So setting up that equation, we can then simplify this, so timesing into the bracket there, and then we want to get all the x's to the left and all the y's on the right. You see, we need to get to a ratio for the amount of black cows to the amount of brown ones that we actually need for this situation to happen. So if I can get all the x's on the left and all the y's on the right, then I am looking at a ratio, in fact. So simplifying that, taking all the x's to the left hand side, you get 8x, and then subtracting all your y's on the right, you get 5y. And I want a ratio, and remember, ratio is actually a fraction. So if you can get the answer for x over y, okay, that is the same as, talking about a ratio x to y. So whether you have it as a fraction or a ratio, same thing. So I want to get the x and the y alone on one side. So in this case, what I did here is I divided by x on both sides here, and to get the 5 to the left, I divided by 5. And now you can see that ratio coming out quite nicely. So y to x is going to be 8 to 5. Now, if you put that back into ratio form, just to give them their final answer. So what is the ratio for black cows to brown cows? I know that the black cows are represented by x, and in this case, that is represented now by 5. And the amount of brown cows represented by y is 8. So it's 5 to 8, black to brown. A, B, C run a race of 100 meters. A beats B by 20 meters, and B beats C by 20 meters. How far ahead of C was A when he was at the finishing post? Now, to do this question, we need to visualize what is happening here. We need to have a look at the distance covered by each person. We don't have the time and we don't have the speed, but the distances are all going to be in proportion to one another. So looking at the first scenario, you can see that as A finishes the race of 100 meters, because he was 20 meters ahead of B, at that stage, B would have traveled 80 meters. So we know by looking at that if I take the amount of meters that B traveled and the amount of meters that A traveled, I can figure out the fraction of the distance that B has traveled compared to A. So 80 divided by 100 gives us 4 over 5. So 4/5 of the distance of A was covered by B. Then in the second scenario, we again look at the distances there. So they say that as soon as B crosses the finish line at 100 meters, C is 20 meters behind. So again, I want to work out the fraction of the distance that C is covering compared to B in this case, which also gives us 4/5. 80 meters out of 100 meters. So C, the distance that C is covering, is 4/5 of the distance of B. The thing is, we need to know where exactly C is when A finishes the race. And when A finishes the race, B at that stage ran 80 meters. So to find out where B is, we can just, to find out where C is, we can take the amount of distance at that stage ran by B, which is 80 meters, and we times that by 4/5, because C will run 4/5 of the distance of B as A finishes. So C would have run 64 meters. So how far ahead is A from C when he finishes the race? Well, you can see there, I just drew it out for you. If C ran 64 meters and A is at the finish line, then at that stage, A would be 36 meters ahead of C. Farida would like to become an Olympic sprinter. Her younger sister Sumaya would rather play football, but helps Farida by racing against her. When they tried the 100-meter dash, Farida crossed the winning line when Sumaya was still 20 meters short of it. Farida wanted something more challenging, so it was agreed that Farida would start 20 meters behind the starting line. They both ran exactly the same speeds as in the first race. Where were Farida and Sumaya when the winning line was crossed by whoever arrived at it first? Now, to understand this problem, again, I went and drew it out for me. I wanted to see, where is who at what time and after how many distances traveled or meters traveled. So in the first scenario, this is the first race that took place, and they said that Farida won the race. She was 20 meters ahead of Sumaya. So we can see it's very much the same as the previous example, same distances were used. So if Sumaya ran 80 meters, Farida ran 100 meters in the same time. So we again can get the fraction of the distance that Sumaya is running to that of what Farida is running. You can also maybe look at it as a speed, because the fraction of Farida's speed is going to be the same as the fraction of Farida's distance. So it doesn't really matter, but it's going to be the same as the previous question. So 80 divided by 100, you can see that that's 4/5. So Sumaya is going to run 4/5 of Farida's speed, and she's going to run 4/5 of Farida's distance. Now we need to look at the second scenario. So again, I just drew out the first race. We know that when Sumaya runs 80 meters, Farida will run 100 meters. And that ratio will always stay the same, no matter where Sumaya or Farida is. So the second scenario says that if Farida is 20 meters behind Sumaya when the race starts, so Farida needs to run that 20 meters. And then we know that as soon as Farida runs a full total of 100 meters, that's going to be the same as Sumaya running 80 meters. So after 20 meters and another 80 meters, the two are exactly next to one another. They are lined up. But from the previous question, we know that if Sumaya runs 4/5 of the distance that Farida runs, we can actually work out where Sumaya is, because we can see at this stage where they are lined up, Farida only needs another 20 meters to run 100 meters. So remember, the 100 meters starts there, and after 80 meters, Farida still needs to run at 20 meters to win this race. So we want to know where exactly is Sumaya at this point. We know that Farida needs to run 20 meters. So 4/5 of Farida's distance will be the amount of distance that Sumaya would have run at that stage. And that gives us 16. So how far ahead is Farida from Sumaya? That would be 4 meters. 4 meters difference. And Farida will definitely win this race. Then for our last question. 2 cars race around a circular track at constant speeds, starting at the same point. If they travel in opposite directions, they meet every 30 seconds. If they travel in the same direction, then they meet every 2 minutes. If the track is 1,800 meters long, what is the speed of each car? Now, to explain this, again, I drew out the scenario so that you can see visually what is happening here. So the red is the first car, the blue is the second car. We don't know how fast they are going, so I'm making the first one speed X and the other one speed Y. And I know that they start at the same point and they drive in different directions and meet up after 30 seconds. So to get the amount of distance covered, or the actual time, the time that this is taking place, is the total distance, which is 1,800. That's the complete distance around this track. So it's 1,800 meters divided by the total amount of speed, you see, to get the amount of time. So distance divided by speed. And here I'm adding the two speeds together as to get them to the same point. Now the other scenario works a little bit different. Here the two cars start in the same position, but they drive in the same direction. So you can see the two speeds are doubling up everywhere, and we don't want them to double up. We just want the total speed for them to meet up again. Okay, and we don't want to double up on that. So in that case, we take the total distance around the track, but then we subtract the speeds to not have double total speeds around the track. We just want one car's speed in that case around the track. Equals 220, because this is my amount of time that this is taking me. And now we need to solve these two equations simultaneously. And to do that, you have not done this in your syllabus yet, but this is just a slight substitution. It's not a very hard calculation to do. So to show you how we do this in the easiest possible way is we firstly take this denominator here and we times it to the right hand side. So this x plus y is multiplied with 30. Now if I do that, 30 is times by x and 30 is times by y, and then the denominator is gone. So you can see the red equation becomes 1,800 is equal to 30x plus 30y. I then do exactly the same with the equation on the right hand side here. Again, I'm going to times 120 with x minus y, and I then get 120x minus 120y. And I then go and line up these two separate equations underneath each other. And what I want to try and do is to eliminate one of these variables. So you can see here, 30x minus 120x is not going to cancel. But if I take 30x and I times it with 4, that is actually going to give me 120x. And then if I subtract these two, the x's are going to cancel. So that's exactly what I did. I want one of these variables to cancel out when I vertically subtract or add, depending on what your calculation is. So here I need to subtract, but if I times by 4 here, I just need to make sure to times the whole equation by 4, and then I can work that out. So let's see, if I take 1,800 and I times that by 4, this is going to give me 7,200. I know that that's 120x, and then here I get another 120y. Right, now I need to subtract. So I'm going to subtract the bottom equation. So 7,200 minus 1,800 gives me 5,400. I then subtract 120x minus 120x, and that will just cancel. So you'll get 0. And just be careful here. 120 minus 120, because I need to subtract the whole equation at the bottom, and a minus actually becomes a plus. So 120y plus 120y gives me 240y, and to get y alone, we divide by 240, and we get the speed, the meters per second for my first car. And then to work out the speed of the second car, you can just sub that back into one of the equations. So let's see, it's 1,800 x plus y, so you just sub that in, is equal to the first equation said 30. And then you can work that out just by timesing that to the other side. 30 times 22,5, that gives us 675. Then moving that to the left hand side gives us 1,125. And then finally, to get x's answer, you are going to divide this by 30. And that is where this answer of 37,5 comes from. So these are the two speeds of your two cars. And the algebra here is a little bit complicated. We call this simultaneous equations, solving the equations together by using the method of elimination. You can also use substitution, but I just wanted to, do this in the shortest way possible. So that is it.